So who's going to speak next?
I think we've got a classic Thoughtworks pairing. I mean, we love pairing, and we've got a pair coming up. So I'm going to introduce Andy Marks because Andy, he, him, as the regular expressions of his pronouns. I love that. Consultant for so long, I can't even remember. I think we don't have enough digits in the Thoughtworks HR systems to measure how long he's been here. I know Andy as a teacher of many things, and he still has that role in many ways. He's been round the world, classic sort of a Thoughtworks thing. 1996, he's been writing code professionally since. That's closer than the year 2050. That's how that is. In Melbourne, Brisbane, San Francisco, Leeds, and Singapore, joining us as a tech lead in 2002. So I think that makes it around 20 years, which is just, I love, it's remarkable. Congratulations. A regular speaker, many of you would know Andy. I know him as the bass player for the Thoughtworks band in the Battle of the Agile Bands every year, and what a generous and wonderful spirit he is, and creative. Now, your turn to introduce his pair.
And we have Pam Rucinque joining Andy. Pronouns are she or her. And Pam has this amazing capability to kind of grasp any complex technical information, and she can just produce a much simpler version of the whole thing. And she's actually well known for producing much simpler designs, making it cost-effective, making it easier to implement. And many a times, actually, I have seen her challenging the status quo on the ground. And she's actually well known for her immense contributions to the tech lead community at Australia.
What's the title of the talk?
Yeah.
It is Reviving the Art of Software Design. What's old is new again, apparently.
So Luke mentioned a lot about thinking about sustainability, thinking about software design upfront, thinking out-of-the-box designs, and even kind of measuring if something is sustainable or not. So how do we do all that? Can you please tell us?
Welcome to the stage.
What a wonderful introduction. I don't feel old at all at the end of that. All right. So I'm going to let this question just kind of hang in the air a little bit, like a kind of bad smell that no one wants to take responsibility for. But rest assured, Stack Overflow is going to come back into our narrative a little bit later on. Right. Let's get started. Let's get back to where I guess the genesis of this talk came from. And we need to go all the way back to the start of 2022, when myself and a bunch of colleagues, fellow Thoughtworkers, were quite interested in the behaviour of dogs and foxes. Now, most of you, I suspect, probably recognise this as the canonical pangram in English. A pangram being a sentence that contains every letter from the corresponding alphabet once and hopefully no more than that. Curiously enough, little side note, when we did this presentation in Sydney, this actually wasn't a pangram. I got one of the words wrong. Thankfully, someone gave me the feedback. It now definitely is a pangram, or at least I'm pretty sure that's the case. So myself and my colleagues were looking at this particular pangram, this particular bit of text, because it was input into a little JavaScript program that was going to tell us whether or not it was a pangram. In fact, we weren't looking at just one or two or three of these programs. We had about 12 of them laid out before us. All JavaScript, all functionally identical. Same set of unit tests were green against all of these. So from an external point of view, they were the same. Internally, however, very, very different. We'd picked these 12 because they exhibited a wide range of different approaches to software design. Different people had written each one of them. They all had their own experiences, their own preferences with writing code, and you could see all that stuff. And myself and my colleagues were there to look not at the external functionality, but at the internals, at the way these solutions had been designed. And we were trying to rank them from best to worst. Another side note, we didn't agree, by the way. That may have come as a surprise to no one. We could not agree on a definitive order. But, and this is where Nigel has stolen my thunder, there were lots of regular expressions involved in many of these solutions. So we spoke about that. We spoke about what is the right level of regular expression to put into a problem like this. Many of my colleagues immediately said, none. There is no right level of regular expression for this. Some people nodding in the audience, fair point. There were lots of set data structures as well, scattered across the 12 different implementations. And sets are nice because sets guarantee uniqueness of entries, which is really good for this sort of problem. But we also spoke about, is it reasonable to expect that a kind of typical developer coming into one of our teams would see a set and then understand that behavior of the set and therefore understand why the set was being used? And so on and so forth. This conversation evolved. And it was about 90 minutes. It was wonderful. It was so much fun just to spend time talking about this sort of stuff. Because this is very much at the heart of what I love about software development. That once we've gone beyond solving the problem for the customer, how are we going about solving that problem? What's the quality of the code we're writing? What's the quality of the software design? Because I worry that those sort of conversations aren't happening enough anymore. I certainly don't see them happen in the clients that I'm privileged enough to work with. I don't see them happening at Thoughtworks either, and apologies to all my colleagues in the audience. I think this is something which is drifting away from us as an industry. Which comes to our central premise, that we, and I mean the most inclusive definition of we, Pam, myself, everyone in the audience, everyone in the IT industry who's not here, are bad at software design. We're bad, we are not getting any better, and we're possibly getting worse. Now, of course, there are reasons for this. They're very rational, valid reasons. COVID and remote work, I actually think, has a part to play, because I think a lot of those conversations that we were talking about were water cooler conversations. They were organic conversations that we didn't plan for, but happened because we were physically in the same place. So I think that is a reason, but I've seen this happen over a much longer period than COVID has been with us, and we're going to talk about what some of those broader systemic reasons are. Rest assured, we both believe that this stuff is still important. It is still really important as an industry for us to be good at software design. I think we've tried to make that not be the case. I think we've done and we've tried lots of things over 10, 15 years to kind of mitigate the risk of not having enough people who are good at software design, with probably only marginal success. So if you think that maybe software design isn't important anymore, then we humbly and respectfully disagree. And we'll talk about why. Okay, here's the hook. Everyone in the audience who is an engineer or working with engineering teams, we all are part of this. We are part of the system that impacts on this situation. We are all responsible. But that also means we also all have the ability to be able to address this. If you see this personally or within your team or within your organisation, you have the ability through your influence and the experience you have to be able to possibly move this lever, even if it's just a little bit. Just a little bit. Because the change that we need sometimes can start really small. All right, so enough about the fact that this is something that I personally get a lot of fun out of. Let's come back to probably more relevant reasons about why we care. Ah yes, the fine print. Fine print always gets you. Okay, everyone, please. Let's see if we can do a better job than Sydney. I'm sure we can. I want everyone to embody your best Darth Vader impression and give me a forced choke hand. Stretch those fingers out. You are trying to choke someone with an incredibly thick neck. Stretch out. Okay, very, very good. Relax just for a little bit, but now, both hands, you are now hugging a medium-sized elephant. Come on, stretch those arms out. Stretch those arms out. It's good. It's just good because we've been sitting here for a while anyway. Thank you, thank you, thank you. The reason why I got you to do that, apart from the fact that it looks amazing from the stage here, is because the difference in distance between your forced choke fingers and that is a reasonable proxy for the difference in the cost of building a piece of software initially to the total cost of that ownership over its lifespan. Now, depending on what research you look at, you get different numbers, but the ones I've looked at, none of them are particularly recent, unfortunately, talk about the maintenance cost of software being somewhere between 75 and 90% of the original build cost. And the software design stuff that we're talking about really comes into play over that 75 to 90%. So that's a reason why we care. Now, our good colleague Martin Fowler who couldn't make it today, although I don't think we invited him, so that's okay, also has stuff to say about this as well. He has a slightly clumsily named Design Stamina Hypothesis blog from 2007, which talks about our ability to be able to add software over time and what happens to that ability depending on how much effort and how much attention we've paid to software design. And he posits kind of two scenarios here. That if we're not investing in software design, or I guess if we're doing a very bad job at it, then early on, no problems. We have no problems being able to add functionality. As the x-axis progresses, so does the y-axis as well. Not really a big issue there. But then that line starts to tail off. Then things get harder. Then things take longer. The thing which was an afternoon task way back then is now a couple of days. Now, I fear and I suspect that for many of us, we're living our lives, our work lives, partially or wholly, somewhere on the right-hand side of that graph, where the software we're dealing with, the software we're responsible for, the software we're contributing to is taking a long time to be able to continue to add stuff to. And quite frankly, that sucks, because life's too short. Time is too precious to be over there. Now, the other line that Martin posits is what happens if you pay attention to software design and you keep paying attention to software design as you go through. Now, a couple of interesting points here. It's slower. Out of the box, it's slower. It takes longer. You don't get as much functionality added because you're spending a big chunk of your time trying to evolve the design. So it's kind of matching the direction that the application is going. But it's not always slower, because those lines cross over, and from that point onwards, it's kind of all gravy if you're on that green line, or something approximating that green line. Now, the big point is, when do those lines cross? When does that, if you drop a line down to the x-axis, to the time axis, when does that happen? And the hypothesis says that if you are hoping, planning that that is months and months and months, and hopefully maybe in the next financial year, and maybe someone else's problem, then it's probably a lot sooner than you may think. This is probably going to come and bite you much, much sooner than that. So that's why we care. But it's not the only reason why we care.
Thank you, Andy. Good morning. So our industry has moved towards a more distributed architecture. We're now in the microservices serverless area. And designing for distributed systems is complex. I think we can all agree with that. There's something that might not be evident, though, and it's the fact that people earlier in their careers are having to make decisions that in the past, when we were in monoliths, were mostly made by architects or people that had a lot of software design experience. Because when we were in the monolithic architecture era, we had a large surface for what we're going to call inside-the-box design. So we had to connect classes and components within the same code base in the same deployable. And we did have some integrations that we have to make, like decisions of outside-the-box design, in some of them. And they were made mostly by senior folks. So now that we're in the distributed systems era, that has flipped. Now we have our features built over a lot of components in different technologies communicating over the network. So the surface area for out-of-the-box design has increased. We have many more decisions to make, so they can't be exclusively made by senior folks. And we are going to make mistakes, because that's how we learn. We're human. People that have less experience in software design are more prone to make more design mistakes. The problem is that a mistake in a distributed architecture, it is a distributed mistake. It is harder to diagnose, and it is harder to rectify. But how do we end up here? You like lazy, but we're not, we're not more lazy now. We're not lazier now, or negligent. They're perfect, valid reasons why we are in this, what this trend has happened. And I'm going to start with the first one, which we think is the most important. Nowadays, we have to know a lot about a lot. I'm going to show you a picture which you probably have seen before. It is horrible. Don't look at the detail. It's not good for slides, but it's good for contrast. That's the cloud-native landscape. We've seen this in Twitter many, many times. Has toolset that we need to develop cloud-native architectures. It is large. I'm not saying we all have to know everything that is in there, but we do have to know a lot of them. It's good for contrast, that image, because that is the image of a toolset that I had to learn when I first started my career building in a monolith. I had to learn 5 tools, and I had the time and practice to do that, and I knew them very, very well. I mastered those tools. But nowadays, we're spread too thin. Developers are spread too thin. They have to learn a lot of tools, and when they sign up to learn one, something else might come up, and their knowledge is no longer relevant. So our knowledge right now is very shallow, or shallower than it used to be. So that's reason 1. Reason 2, I talked about it a little bit before, but now the point that I want to make here is how, now that we moved to more distributed architectures, the average code base size has decreased. And the point here is that that apparently has tricked us into thinking that software design is no longer relevant. But the code hasn't disappeared. Code's still there. It's just that it's spread out in many more code bases. So now we're dealing with more code bases that are smaller, but we still have to build systems that are decoupled and highly cohesive. It's just that instead of communicating those components or organizing those components inside the same code base, we now have to organize them over the network. But software design is still relevant. That's second one. And the third one is the way we are approaching or addressing design. We used to read books, software design books that talked about principles and patterns. Not only the principles and the patterns, but the reasoning behind those principles and patterns. So we understood why those principles existed. We were able to recognize when the code and when to apply that pattern and when that principle was present in code or not. Times have changed. That's fine. We consume information differently in many different ways. The information is also more specific. It's shorter and to the point. So that has changed. But we also have something else that has changed, and it's the fact that now we have tools that make design decisions for us. We have Jetpack Compose, we have Spring Boot, many others, we have React Native. And those tools have their place. Like, for example, if I am going to build a React front end, I am not a React expert. I am going to trust a tool like React App to do the scaffolding for me because I trust the React experts that build the React App tool to make those decisions for me. So it makes sense. The second one is Stack Overflow. We took it, the sourcing of design, we took it further. And we are now searching online what is the best way to do X, Y, or Z. And we go to Stack Overflow, we take the solution, we copy-paste it into our code, or we apply it, and then we move on. Things that now we don't even have to leave our IDEs. Things like GitHub Copilot are right there, and you just click. With a click of a button, you can accept a suggestion that a tool is making to you. Again, I'm not saying these tools are bad. They have their place. The problem is that we used to we used to make software design decisions day in, day out. But not, because at some point we're going to have to make important design decisions. So making the small ones prepared us for those important design decisions. But now we're not making those design decisions. We're not exercising our design muscles. We're basically paying someone else to go to the design gym for us. But we are positive people, and we think we can turn this trend around.
The issues that come about through lack of software design or lack of good software design, this is fundamentally a people issue. So there's people at the start of this cycle, and there are people at the end of this cycle as well. So manifested from a technical perspective, but this is a very social, humanistic thing. So a lot of the recommendations that we're going to be talking about are, unsurprisingly, about people and about behaviour. We've got about 5, we've got a handful of these that we want to talk about. I suspect, in fact I hope, that for a lot of people in the audience here, for a lot of the organisations, your employers, you are doing some of these things or something which kind of looks like some of these things already. And I love that for you, that's really good. We do hope there is at least something here for everyone though. Some of these are easier, some of these are harder. We're going to start with the hardest one, although the title doesn't really give it away. What we're talking about is if we have an organisation or a work context where there is no time to pay attention to software design, that needs to change. We have to fix that. We have to push against that. Software design needs to evolve. Again, I'm privileged enough to work with lots of clients in Australia, and sometimes I'll go into a client and it won't take too long to suddenly get a sense that the prevailing unspoken culture in engineering is ship the first thing that works. It passes the acceptance criteria for the story, ship it, push it out the door. There's like a little virtual demon sitting on the shoulder of every engineer and the people within the teams, effectively saying that. It works, ship it. You've got to ship it because there's the next story after this one. And then there's the next story. And then there's all the other stories until the end of the iteration. Then there's all the other stories to the end of the release. Then there's the end of the backlog, which is 2025 or beyond. We don't have time to do anything else. We don't have time to go back and put out the fires that we accidentally lit getting this current thing to work. We certainly don't have time to go back and address the bigger steaming piles of software design that are getting even smellier over in the corner. And quite frankly, this is bullshit. Sorry, I'm just waiting to see if it translated that properly or not. Yes. Yeah. So it spelt it wrong in Sydney. It only had one L. I don't know what's happening there. Apologies if there was someone quite young in the audience. I hope they've gone, because I don't like swearing. So I'm speaking to the engineers right now, the engineers in the room. The last responsible moment, in most cases, for shipping the first thing that works is when you're at university. Last responsible moment. Beyond that, as soon as you're being paid as a software developer, that's not acceptable. That ship has sailed. To the people who are working with engineering teams, if you're in an organisation, if you're in a cultural context where it is hard for the engineers to talk about the need to take time, if everything is go, 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 feature, 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 that's also an issue. Unsurprisingly, I don't have the minutes nor the hours, days or months to actually give you concrete recommendations around this. But fair to say, if this characterises your work environment, as soon as it works, ship it, then unless that changes, even a little bit, none of the other recommendations we're going to make are really going to have much of an effect. On that happy note, let's move on. Okay, so talking directly to something Pam said about the technology sprawl, about the breadth and the depth, the number of tools which are in the toolbox of most engineers. This is something to kind of help that a little bit. And I'm not speaking to the engineers now, I'm speaking more to if we have any kind of CTO, head of tech type people in the audience. And because this is about constraining technology options, trying to take a few of those tools out of the engineers' tool bags so that they have a little bit extra time to work on a slightly smaller set of tools, and they can hopefully get a little bit better at those tools that are left there. Now, before I go any further, I've got a couple of little kind of scratch tests for working out whether this is something which you need to do within your organisation. And there are a couple of rhetorical questions. Both of them have two parts. First one is, do you know within your delivery teams how many different user interface testing tools are being used if you're doing web dev or mobile dev? The number, I suspect, is probably greater than one. And if it's the case, the second part of the question, do each of those tools justify their existence? Is there value that's being delivered by each of those tools that it makes sense to have 2 or 3 or 4 or 5 or 6 of those? Next question, this is more of a power user question, set of steak knives with this one. Do you know how many logging libraries and frameworks are kicking around your code bases? How many different ones? I guarantee you that number is bigger than one. I could very easily reach into double digits. Same question. Do each of those justify their existence? Are each of them there for a particular reason? Because what we find, again, as consultants, is we go into organisations and we get to work in and across delivery teams, and sometimes we'll be working in an area where we have 2 delivery teams that are organisationally neighbours. So like org chart, reporting line, delivery team, org chart, reporting line, delivery team. Same code base, same customers, very similar features that they're delivering. You look at the tech stacks of those teams, and at the core, they're the same because it's the same code base. But orbiting around that core is a very, very bespoke, snowflakey little asteroid belt of interesting technology choices. And it's usually because those teams have been empowered. And I don't use that term ironically. I literally have been empowered. They've been allowed to make technology decisions around their tools, which is absolutely the right thing. I'm not saying we wind back that idea. But if you have teams that are making those decisions in complete isolation, without any alignment back up into the org, you do get like this Cambrian explosion of technology. Now, Thoughtworks Tech Radar is a tool, nothing magical about it, many ways of doing this, but as a way to begin to try and understand how many logging libraries, how many user interface testing tools and other things that are kind of kicking around your organisation as a precursor to trying to maybe limit that number to allow your engineers to get better at a smaller set of tools. That's a reasonable way of doing it. It's great to be able to say to everyone in your organisation, this is our core tool set. You can pick any one of these things from here. Over here, we're experimenting, we're kind of playing, we're trialling and assessing these few things over here. Not for widespread use, might end up not passing, might end up coming into the core. Over here, in this dark corner of the room that no one talks about at parties, is the stuff we don't want. It's either the stuff that we don't want to come in the door or stuff that was currently here that we want to kind of push out. So the radar gives you that ability. All right, so they're the 2 hard ones, recommendation-wise. Going to get some easier ones now. And again, to Pam's point about the way we consume knowledge, about the way that we understand what software design, what good software design is about, this is a great one for trying to raise awareness. And it's very, very simple. It's a book club. That's all we're saying. Now, if you close your eyes and if you kind of mentally picture a book club, it might look a bit different than what I'm suggesting here. You might be seeing like blazing fire, stuffed leather couches, cups of coffee or tea and cake, but kind of lift that general idea and kind of plonk it into a corporate environment, and you just have something fairly simple. You have some passionate software engineers who love this sort of stuff. Break open the discretionary budget piggy bank and spend a couple of dollars on EPUB versions of whatever books make sense. Spend a couple of hours each month going through one of these chapters. We talk about coupling, cohesion, connaissance, the value of immutability over and over ad nauseum if we are talking about software design. The frameworks that we are using are built upon those principles. Not many people kind of know where those terms first came into the industry. The people who knew this stuff are very likely aging or have aged out of engineering roles, possibly out of the industry completely. Simple on that. Next one, if awareness is at the right level, if you have people who understand what good software design looks like, give them a place to be able to do it. The same way you get good at being a software designer, at being able to write good quality code, is the same way you get to Carnegie Hall. Practice, practice, practice. Need a safe space, and again, you need time to be able to do this practice. But there are lots of tools, there are lots of things that you can lean on, whether you're looking at distributed system design, architectural cadres, whether you're looking at code level stuff. The list of things on the left there could have been 4 times as long as that. If you're interested in where the 10, 12 versions of the Pangram code came from, they came from exorcism.io. Safe places, tooling support to be able to get people just to practice on this sort of stuff. But we're not going to stop there.
Thanks, Andy. We are very good right now at verifying the things that we build for our users. So we have tests for functionality everywhere. Then we can use the same process for verifying the decisions that we're making, how it impacts our code and our systems. And there's this concept called fitness functions. I'm not going to go in depth about what they are. In a nutshell, they're just checks. Checks that can be manual, checks that can be embedded in your pipelines, there can be scripted, just checks that verified how, when you make design decisions, how they impact your code. And you can check for the things that you care about. You're probably already doing a lot of this. Linters, for example, allow you to codify the decisions when you decide how you want your code to look like. You can codify that in a linter and check it over and over. And sometimes, like SonarQube, tools like that just get a lot of bad reputation. But SonarQube has a very good score. I got a score that I really, really like, which is called cognitive complexity. How difficult it is to understand your code. And that's for the inside-the-box design. But you can check for things on the outside-the-box design as well. Things like observability, how observable your systems are. Do they have logs that can be parsed by a machine? Do they have metrics? Are they debuggable? Do they have a correlation ID? So these are things that you can also do to improve the software design practices in your teams. Now we're coming to the end of our talk, but before we leave, I want to just give you in a nutshell what we've talked about today. We started by telling you why we care about software design, because well-designed software, it's easy. It makes it easier to introduce changes in the long run. But it's also important because now that the components are communicating over the network mostly, making those design decisions early on allow you to have loosely coupled systems and highly cohesive over the network, so it's quite important as well. We then went into seeing the environmental reasons why we ended in this position. I'm not going to go through them, we already discussed them. And finally, we talked about what you can do at an organizational level, ways of working, things in your teams, and things at an individual level that you can do to improve the software design habits of your organization or yourself. And I want to finish with this quote, which I'm a big fan of. It's Ken Beck's quote, who says, "When making software, you make it work, make it right, then make it fast, in that order." Because I think it captures the essence of our talk. We think we're missing that extra step between making things work and making it right. And we have a decision to make. And it's whether we continue building software that just works, that we probably have to throw away in a couple of years because instead of enabling the business, it has become an obstacle. Or we pay the price now and we invest the time and the effort into building well-designed software that lives for longer and evolves with our customer needs. Thank you.